I don't treat this as the upper function, if I treat this as the upper function, then guess what? This becomes a positive area. And so that's why it works. That's why the integral works whether the function is above 0 or below 0. Okay? Now, if it's the first time you've heard this, this may not make a whole lot of sense. You might have to watch the video again. You might have to ask me questions later again. But suffice it to say that it doesn't matter if we have this function right here, and I'm looking for the area underneath this curve right here, or if I have this function and I'm looking for the area under the curve, I put that in air quotes, and above and between the curve and the x-axis. Okay, there's B, and here's A. The integral gives us the sum, the positive sum of all of these areas. Okay, that's the area, the integral. All right, so you don't have to worry about when it's positive, when it's negative, what the upper function is, what the lower function, because the upper function will be the one that's always on top, and the lower function will always be on the bottom. If you just take the antiderivative of the entire function, it works out, it takes care of itself. It's like if you have 0 minus something, you get a negative. But if you have something minus 0, and this is treated as a positive function, see, look, it treats it like this. It flips it around. And so you take this area, which ends up to be positive, right? That's what it does when you reverse which one is the upper function. So the question was, what if we have two separate functions and you're trying to find the area between? Is that what you're saying, right? So let's say this was at 1, y equals 1, and this is just f of x. If I'm trying to find the area in between these two, okay, then you have to actually subtract the differences here, right? Okay. So this would be f of x, minus 1, and you would take the area, and this would be the area that you would get, okay? And when you did the antiderivative and all that sort of stuff. If you look at this function as one complete function, okay, and then you find the area between this function and the x-axis, okay, watch this. If I subtract 1 from this function, and I take the area between the function and the x-axis, okay, this area is identical. I just moved everything down 1. And so that's with a straight line. So here's the difference. Here's two separate functions versus here's just one complete function, and the x-axis is always the lower function, the other one. Okay? So you're going to get the same area. So if you have two functions and you're trying to find the area in between them, all right? Now, here's the thing though. If the two functions overlap, like you said, if they overlap, then you still have to consider, okay, if I'm using two separate functions, I'm going to have to consider which one's the upper function, which one's the lower, because if I don't, then this one's going to be positive, one's going to be negative, and you're not going to get the total area. Okay? But if you treat it as one function, okay, if you were to combine these and treat it as one function and just take the area between that combined function and the x-axis, then it'll all work out. Okay, so in your textbook here is the fundamental theorem of calculus, okay, where if all f has to be is a continuous function. Can't be any jump discontinuities or anything like that. Not a piecewise function. It has to be continuous. And if it is, then the integral, the definite integral, means this. Use the antiderivative of x, of f of x. So here's our example number 1, which we'll take a closer look at. Right, so in this example, it says, evaluate this. Now remember, evaluate means give a number answer. So we do have limits of integration here. Right? So this is a definite integral, so we're going to be able to find an actual number. Now, when the function is really easy and straightforward, a function that we can easily find an antiderivative for, the integrals are easy. As we say, as we move on, they'll get a little tougher, but for now, all you have to do is find, this is f of x right here, so you find capital F of x right here, the antiderivative, right? Up the exponent, whatever number that becomes, you put 1 over and multiply that. And so here we go. The fundamental theorem of calculus now says that in order to do this, all we have to do is evaluate the antiderivative at 2 and subtract the value of the antiderivative at -1. Okay? And here we go. So you plug in 2, you plug in -1, you should get a value of 15/4, or 3.75. Okay? There's a couple little rules, okay? Where are those? Oh yeah, I'm going to come back to this page here. I just want to take a look at the rules here. When we have an integral, properties of integrals, okay, they're very much the same as derivatives. So that's really nice. They're very much the same. If you have a constant, okay, like 4 times x, you could really pull that 4 out and just deal with x. That's going to be handy. It's going to make integration a bit easier. Also, if you have 2 separate functions, like x cubed plus x squared, you can take the individual integral of each and add them. Okay? And that's the same for definite integrals as well. So let's back up and talk real briefly about indefinite integrals. Okay? Now, indefinite integrals, okay, different than definite. Indefinite are basically, they are equations. Okay? They're functions, I should say, relations. They have the x in them. There's no value to them. And this is when, again, you have to be careful. You have to add c to an indefinite integral. So just like when we were talking about derivatives, antiderivatives, right? The general antiderivative, remember that? General antiderivative, that's the same thing as indefinite integral. So really the general antiderivative means you have to add c at the end because you're not really sure what that constant might be. Really, that's the same as the indefinite integral. And you have to do the same thing. You have to add c. Okay? So check out this table. This is really important. It gives you a bunch of indefinite integrals, ones that we will use lots, ones that are pretty complicated that you wouldn't be expected to kind of know on your own, but they're basically, hey, the derivative of sine is cos, and so the antiderivative of cos is sine, and so on. Anyways, here they are. Take a minute to take a look at that.